All right, let's talk about functions for a second. A set of ordered pairs is called a relation, meaning there's a connection between the x and y values. Ordered pairs, of course, is x comma y for what we're doing. The x values, the set of all x values that I have written here, is what we're going to call the domain. Now, these are new weird things that we're talking about. The domain is going to be any set of the x values that we're dealing with. The y values, on the other hand, we call those the range. The definition of a function, which is what we're coming up on, is a function is a set of ordered pairs or points that assigns to each x value exactly one y value. This is easiest to explain with a couple of examples. My first example I have written here, I have several ordered pairs or several points. I have 2, 5, negative 3, 7, 4, 5, and 0, negative 1. I'm going to start out with my first set, my x values, and I'm going to call that my domain. So all of my domain values in this case are the 2, negative 3, 4, and 0. Those are all the x values at the points that are written above. The y values, or the output values, are called the range values. Now this is called a mapping. What I'm going to do is I'm going to notice up above I have the point 2, 5. So I'm going to take the 2 and I'm going to map it to 5. Meaning when I take the x value and I change it using a function, it's going to change it into a 5. The negative 3 is going to map to a 7. Now the 4 is also going to map to a 5. That's fine. Your domain values or x values can map to the same y value or range value. 0 is going to map to negative 1. This is actually a function because every x value maps to exactly one y value. In some cases, different x values map to the same y value. That's okay too. So let's introduce some new notation. We're going to have y equals f of x, is how you pronounce this. Now let's talk about what this means. Notice x are my domain values, and y are my range values. F is the function. F is changing the domain values and changing them into the range values. So f of x, or f of 7, or f of a, whatever x value or domain value we choose, f is going to change it somehow. And after it changes it, that result is going to be a range value. Let's demonstrate this with an example. Let's take y equals x squared plus 1. I'm going to rewrite this as f of x. F of x equals x squared plus 1. Notice y and f of x are the same thing. This is not f times x. I know it kind of looks like that with the parentheses, but this is saying I'm going to take an x value. F, the function, is going to change it somehow. In this case, it's going to square the domain value and then add 1 to it. And that output, that result, is going to be a range value or a y value. So now that we have our specific function, x squared plus 1, we're going to do 3 examples. We're going to say, let's find f of 1. F of 1 means I'm going to now evaluate the function f of x equals x squared plus 1 when x equals 1. So this is going to give me 1 squared plus 1. 1 squared is 1. Plus 1 is going to give me 2. Let's do a different domain value. In this case, we'll choose f of negative 3. The domain value is negative 3. We're going to figure out the range value. I'm going to go negative 3 squared plus 1. Notice it's always domain value squared, x squared plus 1. Negative 3 squared is 9 plus 1, which gives me 10. Be careful with the negative, and you put the parentheses. Negative 3 squared gives me a positive 9. The range value in this case is positive 10. The last example for this one is going to be f of 0. Now remember, the x value can be a letter even. I could have x, x plus h, I could have f of a, any value, but in this case, x is going to be 0. My domain value is 0. So 0 squared plus 1 is just going to give me 1. My domain value in this case is 0. My range value is 1. All right. Now, let's talk about the vertical line test. A vertical line test is a way to determine if a graph is a function or not. The vertical line test is if if a vertical line can intersect with a graph more than once, then the graph is not a function. Let's move to our first example and talk about this. I'm going to draw a couple of vertical lines through my graph. So this vertical line crosses my line one time. Let's draw another one. And notice this vertical line crosses again only one time. Do you see that every vertical line will cross this graph one time? That means, according to the vertical line test, it crosses exactly more than once, not more than once like it says above. Therefore, this graph is a function. So yes, it's a function. Let's move on to the next graph. We're going to also draw some vertical lines. And I'm going to notice that every vertical line that I draw in this case is going to cross exactly one time. So this is also a function. This next graph is another parabola. However, in this case, it crosses 2 times. Any one vertical line, if it crosses 2 times at any point, it is not a function. So in this case, definitely not a function. This next graph is what's called the sine wave. As wavy as it is, every vertical line that crosses it at exactly one point. In this case, it is definitely a function. Let's go back up to our first example. Our first example is a straight line. And we're going to talk about what the domain is. Every x value in the whole world can go on. So x can equal 500, 10,000, a million, or negative a million. It doesn't matter. In this case, the domain is any x value. It's going to be from negative infinity to infinity. Same with the range value. There's no limit to how far up it can go, and there's no limit to how far downward it can go. Most straight lines are always going to have a domain and range of a negative infinity to infinity, and they are all functions. There are a couple of weird exceptions to that, but for the most part, this is the case. Our next example, example 2 here, with the upside down parabola, it is a function. The domain in this case actually is going to be all real numbers, meaning I can go as far in the x direction as I want to go, in either the negative infinity or positive infinity direction. However, the range value is limited. My y values, the maximum I can hit is 5. The minimum I can hit is negative infinity. So in this case, the range goes from negative infinity to positive 5. Next example. The domain in this case is limited. The smallest domain value I can get is actually negative 4. However, in the positive x direction, I can go off to infinity. The range value, there's no boundaries. Negative infinity to infinity. My last example, the sine wave here, the domain actually, it continues oscillating exactly like this. This is actually a famous graph. So it goes on forever in the x direction, negative infinity to infinity. However, the largest y value that it can be is going to be a positive 1, and the smallest is going to be a negative 1. So we are limited from negative 1 to positive 1. And there you have functions.